back to my channel. I am Hajra Mughal, your physics mentor, and I'm thrilled to see you again. Today we are diving back into our Mdcat and Ecat prep series, and I'm excited to share more insights and strategies to help you master physics and achieve your academic goals. So let's get started and make today count. So students, get ready to test your knowledge and boost your confidence. Today we are going to explore this exciting world of electrostatics through interactive multiple choice questions. This quiz style session will help you assess your understanding, reinforce your concepts, and feel more prepared for your exams. So let's dive in and get started. To excel in multiple choice questions on electrostatics, make sure to brush up on these crucial concepts like charges, electric field strength, electric field pattern, point charges, Coulomb's law, effect of medium on Coulomb's force, electric field due to an infinite plane of sheet, electric field between two oppositely charged plates, electric potential difference, electron volt, capacitors, dielectrics, charging and discharging of a capacitor, and time constant. A strong grasp of these fundamentals will help you tackle multiple choice questions with ease and accuracy. Okay, so students, first MCQ is two charges of 9 coulomb and 1 coulomb are 3 meters apart and F is the force between them. So the first charge is of 9 coulomb and the second charge is of 1 coulomb and they are 3 meters apart. And F is the force between them, so F is equal into K Q1 Q2 over R square according to Coulomb's law, and Q1 is 9 and Q2 is 1 and R squared 3 square is 9. If I rewrite, so F is equivalent to, if I cancel out 9 with the 9, F is equivalent to K, which is equivalent to the Coulomb's constant. Okay, so the other part is these charges are brought together, so the force between them becomes 4 times. Now the new force is equivalent to the 4 times the previous one. And how much they are apart they are. Now you have to find the distance between them, the new distance. So according to Coulomb's law, F prime equals to K Q1 Q2 over R prime square. The charges, the magnitude of the charges are still same, okay? So F prime is equivalent to 4 times of F, and K Q1 is 9, Q2 is 1, and we have to find the new distance. And if I substitute the value of F over here, which is K, so it will become 4K equals to 9K divided by R prime square. K will be cancelled out with the K, so R prime square is equivalent to 9 by 4. And if I take the root on both sides, so it will be 3 by 2, and 3 by 2 is 1.5 meters. So the correct option is B. Okay, so students, next MCQ is the flux through an area will be maximum if vector area is dashed to the field lines and the options are perpendicular at any angle, parallel and inclined. So students, according to the definition of the electric flux is the dot product of electric field intensity, or you can say the electric field strength, and vector area. So students, vector area is the area that the direction of that particular area is always perpendicular to that particular surface, okay? And if the vector area and these lines are parallel, then this theta, if you open this dot product, then there will be a theta over here. So this theta will be 0 degrees because these electric field lines and the area are parallel, so it will be cos of 0, and cos 0 is 1. So the answer will be EA, like if you can see in this diagram. So if the angle between E and A, or you can say E and A, are parallel to each other, then there will be a maximum flux. And if the theta is 90 degree, then there will be no flux. Like in this figure you can see the electric field lines are in this direction, and the vector area is perpendicular to E. So the angle over here is 90 degree. So when you substitute 90 degree in this formula, then this expression will become 0. So the correct answer is parallel. Parallel means the flux is maximum, and if E and A are perpendicular to each other, it means there will be a minimum flux. Okay, so next MCQ is, if the area of the plate is halved and the separation is reduced to 1/3, then capacitance will be, and the options are same, 1.5 times, double, 4 times. So the relation between capacitance and area and separation is C equals to epsilon naught A over D. Epsilon naught is the permittivity of free space, area is the area of the plates, and D is the separation between the plates. So if the area of the plate is halved and the separation is reduced to 1/3, okay, so this above equation, the capacitance will be, okay, so C is equivalent to epsilon naught A by 2 and D by 3. If I rewrite this equation, so it will become CA over D, and it will be 3 by 2, and 3 by 2 will be equivalent to 1.5, and this is again the formula of capacitance. So it is 1.5 times. Okay students, a very interesting MCQ. Suppose we have two metallic spheres and two charged particles of equal charges are placed inside these spheres, one in each sphere. So first of all, let's say this is a sphere A and this is a sphere B. Okay, so two charged particles of equal charges are placed inside these spheres, one in each sphere. In one of the spheres, charged particle is placed at the center. In one, it is placed at the center, and in other, it is placed halfway on the radius from the center. So let's suppose, if I can write it, it's a radius, so it is halfway. Okay, so what will be the electric flux? The electric flux of the options are, the electric flux of the sphere A is greater than the B, or the flux of B is greater than the A and the equal and cannot be determined. So according to the definition of the flux depends on the total charge enclosed divided by the permittivity of free space. So it only depends the amount of charges, so and the amount of charges in both the spheres are equal. So we can conclude the flux is equal. Okay, so students, next MCQ is, which of the following is true about electric field intensity? It's a vector quantity, it's a force per unit charge, its direction is same as that of force, and all of these. So students, you have started this concept in your second year classes, that, and the formula is electric field intensity is force per unit charge, and you can define it as force experienced per unit positive charge at a point placed in the electric field. So it is force per unit charge, yes, and it is vector quantity, yes, because it has a direction same as that of force. So it's a vector quantity and has the direction same as that of force. So in short, we can conclude that all of these options are correct. Okay, so what is the unit of K in Coulomb's law? So we know that the Coulomb's law is F equals to K Q1 Q2 over R square. K is Coulomb's constant, and what is the unit of K? So first we need to separate K. So when I take R on the other side and charges also on the other side, then K will be separated, and we know that the unit of the force is Newton, the unit of the R square will be meter square, and the unit of the charges will be Coulomb square. So the correct option is A, Newton meter square per Coulomb square. Okay, so the amount of work done on a charge from one point to another point in an electric field is called. It's a definition of electric potential. We have studied in our secondary classes that whenever there is a test source charge, and let's say the source charge is represented with positive Q, and it has its own electric field intensity, electric field, and there is some test charge, and if I take this test charge to the source charge, means I'm doing work on it because I'm moving this charge against the field, against, because they have the repulsive force between them, so I'm taking this charge against the field. So there will be some energy, the amount of energy that will be stored in this charge in the form of work done. So the amount of work done that I have done on this charge is known as electric potential, and the symbol of electric potential is V. Okay, how fast or how slow a capacitor is charging or discharging, it depends on time constant, capacitance, voltage, and current. So students, remember that the RC value is called time constant. The RC value is called time constant, and it determines the time, how slow or fast a capacitor will charge or discharge. Okay, so students, next MCQ is, if the charges are doubled and the distance between them is half, then Coulomb force will become. Let's suppose the charge 1 is doubled and the charge 2 is also doubled, and these are new charges, and the distance between them is halved, and the new distance is also r prime. Then what will be the new force now? So we know that the formula of the Coulomb's force is K Q1 Q2 over R square, and if I want to write the new Coulomb's force that has been changed due to these changings, so the new charge will be twice of Q1 and it will be twice of Q2, and the distance will be half R square, the whole square. Okay, so K Q1 Q2 over R square, 2 into 2 is 4, and this 2 square times, when I take this 2 in the numerator, then it will be a 4. Then 4 is 16, and this is again the old formula. So F prime will be equivalent to 16 times of that force. So 16 times is the correct option. Okay, the flux through any closed surface is dash times the total charge enclosed in it. Epsilon naught 1 over epsilon naught square, 1 over epsilon naught, or epsilon naught square. So this is the statement of the Gauss's law, and Gauss's law says that the total flux passes through any closed surface is dash times the enclosed dash times the total charge that is enclosed in it. So dash time means 1 over epsilon naught times 1 over epsilon naught times. Okay, this is Gauss's law, you have studied in your second year classes. Insertion of dielectric between the plates of the capacitor, and the options are increases capacitance, reduces potential difference between the plates, provided insulation, and all of the above. So students, remember that insertion of dielectric with polar molecules aligns them in the electric field, creating an opposite field. This reduces net field, allows more charges to be stored, and increasing the capacitance and decreasing the potential difference according to this formula. If the capacitance is increased, then the potential difference will be decreased. Then you can say that the option D is correct, as it also provides insulation. So all of the above options are correct. Okay, so next MCQ is, what is the value of intensity of field inside a hollow charge sphere? Maximum, infinite, 0, and 1. So students, you must have studied this concept in the applications of Gauss's law. And its first application in Karachi board, that whenever there is a sphere and it is a charges on its surface, and if it's a hollow sphere, then because it doesn't encloses any charge inside this inside the sphere, so Q is 0 inside the sphere, so we can say the intensity will also be 0. Okay, so the volt is equal to, so we know that from the definition of the 1 volt, if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other, and it's a definition of electric potential, then it is equivalent to 1 joule per 1 coulomb, means volt is equivalent to work done per unit charge. So 1 joule per 1 coulomb is equivalent to 1 volt. So B option is correct. Okay, if the distance of separation between the two charges is increased, the electric potential energy of the system will increase, decrease, may increase or decrease, remains the same. So according to the formula of electric potential energy is equivalent to the Coulomb's constant K, Q1, Q2 divided by R. So if the distance of separation is increased, then the electric potential energy will decrease, because they both are inversely proportional to each other. So B is correct option. Okay, so electric potential is a scalar quantity, vector quantity, null vector, and none. So according to the definition of electric potential, it is the ratio of work done per unit charge, and we know that work done is a scalar quantity and the charge is also a scalar quantity, so that the electric potential will be a scalar quantity. Potential difference is a work done in moving a unit positive charge from one point to another. So as I have just explained you in MCQ number 7, that electric potential is the work done that has been done on a test charge in moving against the field, as the source charge and the test charge both having the same charges, the same nature of the charges, so they have a repulsive force between them, and this charge will not wanted to move towards the source charge. And if I apply force and it covers some displacement, so I'm basically doing a work done on this charge to move against the field, because the field is in this direction, and I am doing work that is against the field, and that work done will be stored in the form of energy, and that is known as the electric potential energy. So I'm doing work done against the field, against the electric field intensity. Okay, a capacitor is a device that is used to store electric charges, a very easy MCQ. So capacitor is a device that is used to store electric charges. The net capacitance of a parallel combination is, and the options are these. So students, remember that the net capacitance in parallel combination is the simple algebraic sum of the capacitance of the capacitors. Hence, in net capacitance is larger than the largest capacitance. So the correct option will be the option A. And this is the formula. Okay, so the polarization of dielectric between the plates of a parallel plate capacitor dash the capacity of the capacitor decreases, increases, neutralizes, and nullifies. So students, remember that capacitance increases. When it increases, when the dielectric material is added, because the material's molecules align with the electric field, and this alignment reduces the electric field strength. So with the weaker electric field, the capacitor can store more charge, increasing its capacitance. So you must have studied the concept of the polarization of the charges. So whenever we have a parallel plate capacitor and you put any dielectric material, or you can say non-conducting material, so the molecules of this dielectric will the charges in this dielectric will lean towards the opposite charges, like negative over here and positive over here, and because negative plate is here, so there will be a positive charge and negative over here. So some of the charges, the effect of some of the charges in the parallel plate capacitor will cancel out because of this polarization, and the voltage will decrease. And we know that according to Q equals to CV, the formula of capacitance, Q equals to CV and C equals to Q by V. If the voltage decreases, the capacitance will increase. So a negative charge moves dash to the electric field. So students, remember that a negative charge moves from lower potential to higher potential. That is against the direction of electric field, or you can say anti-parallel to the electric field. Okay, so next MCQ is work done to move a 1 coulomb positive charge against the electric field through a potential difference of 2 volt is. So the work done to move a positive charge against the field is written as W equals to Q del V, and you have studied this formula in the concept of electric potential, that electric potential is work done per unit charge. So the value of the charge is given as 1 coulomb and the value of the voltage is given as 2 volts. So it will be 2 joule. The correct option will be B. Okay, so students, the time taken by the capacitor to charge depends on, so the formula of the time constant is the product of the value of the resistance and the capacitance. So, and the T is tau is known as the time constant. So it depends on the resistance and capacitance as well. So the correct option is both A and B. Thank you so much for joining me today, students. We have explored some challenging electrostatic multiple choice questions and I hope they have been beneficial. Remember to subscribe to my YouTube channel and enable notifications to stay informed about our latest content. In our upcoming video, we will be tackling some current electricity multiple choice questions. So be sure to tune in. See you in the next video.